Hey everyone! So we have been talking about the idea of alkenes and their addition reactions so far. We know we focus on the carbons which have the carbon-carbon double bond, and there are three kinds of addition reaction. And every time we focus on the ones which had carbon-carbon double bond. There's addition of hydrogen in the presence of nickel, where we add two hydrogen atoms and we get an alkane. There is addition of steam in the presence of phosphoric acid, where we add H and OH on the carbons and we get alcohol molecule. The third one is the addition of halogen in the aqueous state at room temperature, where we add two halogen atoms and we get either a dibromo or a dichloroalkane because we are adding two halogen atoms. Now, how will addition happen if there is alkene only? So if there are alkenes only, because if there is no hydrogen, there is no steam, there is no halogen, then they add on each other. One alkene molecule will add on the other alkene molecule, and that is addition polymerization. Imagine I am drawing the simplest of the alkenes, the ethene molecule. It has two carbon atoms over here, so that's why obviously it is the ethene molecule. I have three replicas of the same ethene molecule, and I am highlighting them with differently colored pens. Now these are three different ethene molecules, and when the carbon-carbon double bond breaks down, these molecules join on each other, and the ones in the corner, they make extra bonds from the corner to show that this reaction can continue with multiple molecules. We draw square brackets around this combination and we write a small n to show that there can be multiple molecules. We can currently see there are three individual ethene monomers, or you can say three individual ethene molecules which combined to give us a rather longer chain molecule. And we call it a polyethene because many ethene molecules can combine to give us a structure that looks like this. Over here, ethene behaves as a monomer and they combine to give us a polyethene. Polyethene is a long chain polymer. Polymer means a compound, a chain which has so many repeated units. And here ethene was the repeated unit. So I drew three ethene in the beginning. I could be doing the same structure with two or four. Imagine I am drawing perhaps now another alkene molecule which is propene. I am drawing the hydrogens over here. 1, 2 and 3 hydrogens over here. Now if we have to focus, obviously we know that these two carbons have the carbon-carbon double bond. There is a third one as well. If we number them, we get to know there are three carbon atoms with one double bond, so it's a propene molecule. Now it's a rather complicated structure. It's propene because three carbons and a double bond. Now in order to make this molecule simpler, I have to do some changes. I want to make the polymer, but before making the polymer, we will make it simpler. So I'm drawing the carbon-carbon double bond. I can see the carbon 1 has a hydrogen on top of it, so I drew that. Carbon 1 has a hydrogen at the bottom of it, so I replicated that. Carbon 2 has a hydrogen at the bottom of it, so I replicated that. But carbon number 2 has a CH3 around it. Even though it's coming from the right side, but even then it is a simple CH3 group. And being from the right hand side does not matter. What matters is it's a CH3 simplified version. So it's a simplified form of CH3. We draw this CH3 group on the top of carbon 2. We can change the direction a little, but it has to be on carbon 2. And now this is the CH3. This molecule is a simplified propene. We make three replicas of the simplified propene molecule. We know what happens. The carbon-carbon double bond goes away and these carbon atoms join each other. So these small molecules are joining each other. From the corners they make extended bonds. We make square brackets on both the ends, and then we write a small n to show that there can be uncountable propene molecules joining together. That is why we call it polypropene. Poly because there are many molecules combining, and propene because this is the name of the monomer, because the propenes were combining to give us a polypropene. So we keep the name of the monomer, we do not change it, we just put poly. You can see I have 3 individual propene molecules combining together. I could be drawing 4 replicas, I could be drawing 5 replicas, but at least 2 should be there. Now imagine I want to draw Polyisopentene. I know that it has to be a branched 5 carbon alkene. I have 4 carbons in a chain, 5th one is a branch, I have a carbon-carbon double bond. Currently I am drawing all the hydrogens of the polyisopentene. I can see this carbon gets 1 more hydrogen and this carbon gets 3 more hydrogens. Now if I focus on the ones which had the carbon-carbon double bond, I highlight them with a green pen. In order to follow properly, I can very simply draw the exact carbon-carbon double bond because this has to be my focus. I want to make this structure a little simplified because it's a very complicated structure. I know there are 4 carbons and my double bond is between 2 and 3. I know carbon number 2 has a CH3 from one side, so I draw a CH3 group, which is the simplified version, on top of my carbon number 2. We can change the direction from right hand side to the top, that is okay. Similarly, carbon number 2 has a CH3 at the bottom of it. We can replicate this structure, we can make it simply CH3, we can write CH3 and we can put it from the bottom of carbon number 2. It's just another way of writing the whole CH3 bonds. We made it simplified. Similarly, carbon number 3 has a simple hydrogen on top of it, so I replicated that. There is a hydrogen on top of carbon 3, and again if we look at carbon 3, it has a CH3 coming from the right side. So we can simply put it at the bottom because that is another way of writing CH3. So a CH3 comes at the bottom. This is still a isopentene rather, but it's a simplified version of the isopentene molecule. It is still a 5 carbon molecule, it still has a double bond. We made multiple replicas, so I'm drawing 3 monomers, 3 isopentenes. I'm making the carbon-carbon double bond go away. And now the monomers will combine, the carbons will combine with each other. From the corners, we draw extended bonds, we draw square brackets, and we put a small n to show that many small molecules are combining to give us a long chain polymer. You can see this is one, this is the second one, this is the third one. They are repeated again and again to give us a long chain polymer. The name is going to be polyisopropene. Why is it poly? Because there are many molecules. Why is it isopropene? Because this is the name of the initial monomer. Monomer is the initial molecule which was the small alkene, and polymer means the long chain molecule made by the constant repetition of the monomer.